Okay, so this is a video about how we deal with negative numbers in addition, subtraction, multiplication and division. So we're going to start with addition and just use some pretty straightforward numbers to begin with. Let's try -2, and now we're going to continue to subtract. So subtract 3 and subtract 4. Okay, now to think about this, what I'm going to do is just put up the number line here. And, well, let's start on the number line with our starting point here, which is -2. And what this says is we need to subtract 3 and then subtract 4. So we're going to subtract 3, so we go 1, 2, 3 to get to there. That's -5. And then we're going to subtract another 4, so we're going to go 1, 2, 3, 4 to get to -9. So -2 subtract 3 subtract 4 gives us -9. I'm just going to think about it in a slightly different way though. If we're subtracting 3 and subtracting 4 here, why are we calling this -2? What does it actually mean? If I use the identity 0, we can say what it means is 0 subtract 2, subtract 3, subtract 4. So it's very important to remember what we mean by negative something. It means subtract from 0 really. And another way of thinking about this is that what we're doing each time is we're adding a negative. So instead of going in a positive direction, we start at 0 here. We're going to add a negative. Well, if we added a positive, we'd go in that direction. If we add a negative, we're going left into the negative. Okay, so we're going in a left-hand direction. So we could say, just to make this a little bit more interesting, we could say 0 add -2 add a -3 add a -4. It's exactly the same as what we've said originally. It looks more complicated, but it helps us to understand what we're actually doing here. Also, because we know that we can change the order of addition, then we can sort of move these around now quite happily, even though they're subtract signs here, minus signs. What we've done is say, well, yes, but as long as we subtract 4, subtract 3, in other words, if we changed the sign here, if the -4 became a +4, then we wouldn't have the same question at all. But we can simply change the order of things. We can cancel that 0 now and just move things around. So we could say, well, let's bring the -4 up front. Okay, then subtract 3 and then subtract 2, and we can just check that on the number line that we can do that. So we'll erase these things here and start again. So our starting point now is -4, so we start here on the number line and we go back or to the left 3, 1, 2, 3. That gets us to -7, and we go back again -2, so subtract 2 to get us at -9. Sorry, this should have been -9 up here. Okay, -9. So we can change the order of negatives as long as you remember we've always got to subtract that number. We can't actually commute, so that if, for example, if we get 3 subtract 4, that does not equal that does not equal, let's just erase that, 4 subtract 3. It doesn't equal 4 subtract 3. Because what we've done there is the -4 has become -3. Okay, we were subtracting 4, we need to continue to subtract 4 here. And so what we're actually saying is that 3 subtract 4 equals 0 subtract 4 plus 3. And that's the rearrangement that we did here. Okay, let's move on then now to think about multiplication. If we've got something like, let's say, let's say 23 times -7. So 23 times 7, well, that would be a problem in itself, but we're going to say 23 times -7. So here's -7 on our number line. We'll just erase these other lines here. So here's -7. And what we're really saying when we say multiply by 23 is take 7 off or subtract 7 23 times. So we're going to definitely go in this negative direction a long way. -7, subtract 7, subtract 7, subtract 7, subtract 7, and so on until we've done it 23 times. And I think you can guess it's going to be the same as 23 times 7. 23 times 7, but just in the negative. Okay? So what we're actually saying is, well, let's just do the calculation. Let's just work this one out. So we must remember to subtract. So that's 0, 0, subtract 23 times 7. So we put our negative sign in here first. And then we say, well, what is 23 times 7? Well, it's the same as, let's just use some square brackets here. It's making it a little bit complicated, but let's say 7 times 20 plus 3. Have we got the same sort of thing going on there? Yeah, we have. So we've got 23 in the brackets here, 7 times 23, which is the same as 23 times 7, and we're subtracting, in other words it's a negative. So we've just rearranged this again just to make life easier for ourselves, and it's very important that we're able to do that. So we've got 7 times 20, let's put our negative sign in first, because we know this is going to be way down here in the negatives. So 7 times 20 is 140. 140 plus 7 times 3, or 3 times 7, well, that's 21. So we've got negative 140 plus 21 gives us negative 161. So we just add whatever's in the brackets first, and then it's a negative. Okay, so that's multiplication of a negative times a positive. It would have been just the same if we'd have done -3 times 7. It would have been -3, so way down here on the number line, 7 times going further and further into the negative. What if we, okay, let's do division next. What if we choose some numbers, keep them simple, keep them whole numbers that we recognize from our times table. So 56 divided by -7 again. -7. What's that going to be? Well, we can rewrite this. Let's just rewrite it in a slightly different way. Let's change it to a multiplication. Now, we've seen in an earlier video how we're perfectly entitled to do that. So we can say 56 times, well, normally it'd be 1/7, but this time it's 1 divided by -7. Okay? Now what we're saying here is that 1 times 56, or 56 times 1, is then divided by -7, or -7 into 1 times 56. So I'll rewrite this 56 divided by -7. Okay? So we haven't got anything different to what we had here. But what we were able to do by turning it into a multiplication is we were able to combine this top here and just show it in a different way. So all we're doing is changing the numbers round so that we can understand what we're dealing with here. Now I'm going to say something a little bit different here. I'm going to multiply now by the identity, which is 1. So for multiplication and division, the identity is 1. and 1 times 56 gets us roughly to where we were before, times negative 7. What if I was to say negative 1 times 56? Well, then I would be changing what we've got here, so we can't say that unless we divide this by negative 1. So a negative 1 divided by a negative 1 gives us a positive 1. Okay? And that's because 1 divided by a negative gives us a negative. 1 multiplied by negative 1 would give us a negative. So it must be that a negative divided by a negative simply cancels the negative. We end up with 1 divided by 1 times 56 divided by negative 7. So again, we're just playing around with the numbers here to think about this. 1 divided by 1 gives us 1, and we end up with 56 divided by 7. But one thing we might have noticed here is that if we divide by a negative, it's the same as saying multiply the top by the negative. So what we can do here is we can say negative 56 divided by 7. Okay, so what I'm doing is I'm just rearranging this again and again to show you how we can recombine, change, rethink how we do things, and not introduce any difficulties at all. So what have we got? We've got a 56 divided by a 7. We can think of that as negative 1 times 56 divided by 7. In other words, what we can do is do this first. So we've got 56 divided by 7 gives us 8. And so negative 1 times 8, well, it must be negative 8. Okay? It's exactly the same, in other words, as saying 1 times negative 8. And if we were on the number line here at negative 8, let's just erase these, then there we would be. Times 1 just keeps it the same. So 1 is the identity for multiplication and division. Okay, you will need to work these sort of things, these things through yourself. You need to try different numbers for yourself, play around with them, rearrange them just as I've done here. But you need to practice, and you need to get this clear in your mind what we're actually doing when we're adding, subtracting, multiplying and dividing by negatives. Now, one final thing that we'll want to do here is we'll want to think about what happens when we've got two negatives in a calculation. So what would happen if we had negative 23? Okay, so we're negative 23 on the number line, way down here, and we're multiplying by negative 7. So we've got two negatives that we're multiplying by. Well, again, we can just rearrange this. So we've got, well, let's do it this way. Let's think of it as negative 1 times 23 times negative 1 times 7. Okay? So all we've done there is we've multiplied by 1 but made it a negative 1, and that's allowed us to drop the minus sign, if you like, in front of here. So we've still got negative 23, but we've split it apart like that just to make, well, so that we can rearrange things, and you'll see what I mean. So we've got negative 1 times 23 times negative 1 times 7. I could rewrite this, I suppose, putting the multiplication symbols in just to make it clear, rather than mixing the symbols. So we've got something like that. And that means we can reorder this, we can commute until we've got 7 times 23, all right, brought that forward, brought this forward, times, let's just bracket these off, negative 1 times negative 1. Okay, 7 times 23 then. Well, we've got 7 times 23 up here we found was 161, so we've got 161. And we've got a negative 1 times a negative 1. Well, if it was a positive 1, If it was just 1, it would stay the same because 1 is our identity. So a negative times a negative must give us a positive again. Okay, cancels out that negative 1. So it just becomes a positive 1. So we've got 161 times 1, which of course is 161. Okay, let's do the same now with division. Let's take our numbers negative 56 and divide by negative 7. And again, we can say, well, that simply equals negative 1 divided by negative 1 times 56. Let's just keep the dividing line going. 56 divided by 7. So we've got negative 1 times 56 divided by negative 1 times 7. Now we can split this apart because this is a multiplication. So we can group, we can associate in any way we want, giving us negative 1 divided by negative 1 times 56 divided by 7. So I've just removed the negatives by putting them over here and associating them with 1. So we've now got this ordinary calculation. We've got negative 1 divided by negative 1 times 56 divided by 7 gives us 8. And, well, if we were dividing by 1, 1 is our identity, remember? Everything stays the same. So if 8 was divided by 1, then that would just be 8. So knowing that, if we're dividing by a negative 1, then it does change it. So it changes the negative 1 on the top from a negative to a positive. In other words, what we've got here is just 1 divided by 1, which is 1. 1 times 8 equals 8. Okay, so you need to practice not only multiplying and dividing by a negative, but also a negative times a negative divided by a negative, and all of this can sound very confusing, but with practice, trying any number, trying random numbers and seeing what happens, working them through in different ways, then you should find it becomes much clearer in your mind what's actually going on. Okay, so let's just finish the video by thinking of a money example. Say somebody had £500. So we say they're in the black, or they've got positive £500, and for some reason they lose £700. So they get into debt. So all we're doing there is we're subtracting 700 from 500, and we couldn't say that they have no money left. We have to say they have negative £200. Here we are. Because if we just said that 500 subtract 700 was 0, well, that wouldn't be fair. You need to reflect the fact that they've actually still owe £200 to whoever it is they're indebted to. So this is another good way of thinking about negative numbers, and in a previous video we talked about levels of liquid, and all sorts of thermometers is another way to think about temperature, all sorts of ways of making sure that you're absolutely comfortable with the idea of going into negative. Of course, the good news will be if the person then manages to add, they will go above the 0 line and they will go back into the positive. So it's backwards and forwards across that 0 line without any difficulty. And the reason we can do that is because whereas when we were thinking in terms of the natural numbers, the counting numbers, we were just thinking of the first thing that we count, so the first pound, if you like, or the first, let's even think about it as an object, the first coin we would count as 1, and then there are 2 coins, and there are 3 coins, 4 coins, etc., etc., going on forever, because we don't want to set a limit in our counting system for the number of coins that we can count. But we needed to introduce the set of integers. We use the Z symbol here for Zahlen. Z is the set of integers. We needed to introduce this negative direction. So first of all, we needed to introduce the idea of 0. 1, 2, 3. And then we needed to think in the negative direction because of this idea of things being owed to somebody, for example, or going below the level of 0. Okay, so that's why we work with the integers, and that's why the natural numbers are quite restrictive. Finally, let's just reflect back on some things we learnt by experimenting with multiplying and dividing negative numbers in different ways. And we can say that we've learnt a few rules. Now, we want to understand why the rules work, but nevertheless, they're good to remember. So the first idea was that, well, the very first idea that we could write down is that a positive and, let's say, add another positive will give us a positive. So all we're saying here is if we have a positive number above the 0 line, if we think about this, and we're saying, say, 2 add, say, 3, or 2 add 3 will give us 5, and so we're still in the positive. So a positive add another positive gives us still a positive. So nothing changes, it's all positive. And in fact, because that's so usual, that's the normal situation when we're counting things and not thinking about going into the negative, we actually drop the positive sign. We don't use the plus symbol when we're working in the natural numbers. But when we're working with the integers, we're going into the negative, then we start finding this going on. So we have a positive up here, but then we add a negative. And that can give us a number of different things. It could still give us a positive. So it could still give us a positive, or it could give us a negative if that one is larger than that one. So then we would go below 0 and we would go into the negative. So these are just things to think about. They're not rules as such, but the one thing that is very consistent is when we get things happening with multiplication and division. So if we have a positive multiplied by, let's write it out so we're not confusing ourselves with too many symbols, multiplied by another positive, then what we would get, well, same as with the addition, we will still get a positive. But if we get a positive multiplied by a negative, then we're saying what that will give us is a negative. So fairly straightforward. A positive multiplied by a negative will always give us a negative. But if we have a negative multiplied by a negative, then, as we've seen, they'll cancel each other out and we end up with a positive. Now, all of this works for division as well, so I don't need to write it out. I can write it out, but just let's use a division symbol here. So a positive divided by a positive will also give us a positive. A positive divided by a negative will always give us a negative. And just as with multiplication, a negative divided by a negative, two negatives cancel each other out, goes back to positive again. Okay, so I hope that's helpful. Do make sure you understand why these things are happening rather than just learning the rules, but hopefully you can have just as much fun and find it just as easy to work with negative numbers as with positives, and combining the two as well.